Hello, I'm quickly going to go through forming ions to make sure that you understand whether we make a positive ion or a negative ion, depending on which atom that you start with. So if we take a metal and a non-metal, for example, so we've got lithium here and fluorine here. You can see from the atomic number that lithium has 3 protons, and if it's got 3 positive protons, it must also have 1, 2, 3 negative electrons. So I'm just going to write that underneath the atom. So this is an atom, and it has 3 positive protons and 3 negative electrons. On the other side, fluorine, its atomic number is 9. So this is an atom which has 9 positive protons and 9 negative electrons. So overall, for both of these atoms, if you take the positives and the negatives and you cancel these out, so every positive cancels out a negative, every proton cancels out an electron, then because you've got 3 of each, overall your atom would have no charge and it would be neutral, and that's why we call it an atom. And the same on this side, if you got 9 of each, they would cancel each other out, your charge is neutral, so this is also an atom. Now, because all atoms want a full outer shell, if you look at the lithium atom at the moment, it's got 1 extra electron in its outer shell, meaning that it's not got a full outer shell, so it will want to do something with that electron to make it have a more stable electron configuration. And the fluorine has 7 in its outer shell, but this shell can actually hold 8, so it's not quite stable, it's not quite in the most stable electron arrangement, so it will want to gain the other electron to fill that outer shell. So the easy thing that will happen here, if you have a look at these 2 atoms, is that lithium would give its electron to the fluorine atom. So lithium would lose an electron, while fluorine would gain an electron. Now, depending on where you're up to with your chemistry, you might have only seen something losing an electron and something gaining an electron. You might not have seen 2 things combining together where one gives its electron to somewhere else. So if I move that on and show you what happens when they transfer an electron from one atom to another, we can look at the ions that are formed. Okay, so I've just moved this up a little bit. So we've got the lithium atom. These little sums here are really helpful if you're not sure whether an atom is going to become a positive ion or a negative ion. So now I'm going to show what lithium becomes when it loses this outer electron and what fluorine becomes when it gains this outer electron. So it means I get to show you both types of ion at the same time. So lithium has lost this outer electron, now looks like this. Fluorine has gained an electron, and now looks like this. And we've done it with dots for fluorine, as it was before, and a cross for the electron that has come from the lithium atom to show where it's come from. So now we need to do these little sums again to figure out what the charge is on these ions. So if we look at the lithium atom first, all we have changed is the number of electrons. We have not changed anything about the nucleus of the atom. If we'd have changed the number of protons, then we wouldn't be able to call this lithium anymore, because protons tell you the name of the element. So if it's still lithium, it must still have 3 positive protons. But we can see that an electron's gone, so it now only has 2 negative electrons. Now, if these cancel out, I'll show you over on the right, we've actually got 3 positive protons and 2 negative electrons. If you have a look at how they cancel each other out, we've got they cancel out and they cancel out, and what you've got left is a positive, just a single positive charge. So we can show that on your atom by putting it in big brackets and saying the whole thing has a charge on it, and that charge is plus. Okay, so for fluorine, again, we've not changed the nucleus at all. That nucleus in there is still the exact same nucleus that's in there. We've not changed anything about it. So it still has 9 positive protons. But we've given it this extra electron. So it did have 9 negative electrons. It's now got 10 negative electrons. And we can see how they cancel out. So for fluorine, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 positives, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negatives. So they cancel out, they cancel out, they cancel, they do. What's left is 1 negative. So we can see that the fluorine is charged the entire thing, so we put big square brackets around it. That whole thing has a charge on it, so that charge is negative. So if you want to work out, I'll show you this here. If you want to work out whether an ion is positive or negative, these little sums of how many positive protons and negative electrons everything's got are really, really handy. So when it's an atom, it should always come to 0 because it should have the same positive protons and negative electrons. Once it's ionised, once it's lost electrons or gained electrons, then these numbers won't balance anymore, and you can figure out what's left over if you were to cancel them out, and that will tell you the charge on the ion. Okay, so there is a general rule that goes with it. So metals, like lithium, they lose electrons and become positive ions. Non-metals, like fluorine, gain electrons and become negative ions. So you can also use that if you want to, but I think these little sums work really, really well because they'll tell you if something is 1 plus, or if you'd lost 2 electrons, the total would be 2, so you'd have a 2 plus ion. Or if you'd lost 3 electrons, it'd become a 3 plus ion, so these sums work really, really well. I'll show you very quickly with calcium how that looks. Okay, so calcium is a metal, and it has 2, 10, 18, 20 electrons. So it's not feeling like it's got a full outer shell because it's got these 2 extra electrons which are going to leave. So to turn this into an ion, the 2 electrons are going to go, and what we'll end up with is calcium. Still got that shell, still got this shell, still got that shell. And if you look at the numbers on periodic table for calcium, it'll tell you that calcium has 20 positive protons and therefore 20 negative electrons. So overall they cancel out to give you 0. It's an atom, no charge. Calcium ion, we've not changed the nucleus at all, so it will still have 20 positive protons, but you've lost 2 electrons now, so it actually only has 18 negative electrons. And if you were to cancel them out, 18 of your electrons would cancel with 18 of your positive protons, and that would leave 2 positive protons left over. So your charge on calcium, big square brackets, is 2 plus. And it works the same with non-metals. If they gain 2 electrons, they'll become 2 minus, or if they gain 3 electrons, they'll become 3 minus. So hopefully that helps you to understand whether something becomes positive or negative.